Hello everyone and welcome to my channel. Today I am going to be talking about what Basic09 refers to initially as complex types or complex data types. Later in the manual it refers to them as user-defined types or user-defined data types. To me they resemble records. So that's what I refer to them as. And the reason for that is if you look at this example down here, this is your basic contact information that you would have in a card file. Last name, first name, middle initial, address, city, state, zip code 1, and in modern times the zip code 2, so you have the extra 4 digits, and then phone number. And it's all defined under the variable name contact. Then in your procedure, if you wanted to call your procedure Rolodex or something like that, you would be able to cycle through all the different records you have for all of your clients or customers or whatever they happen to be. So that's why I refer to them as records. It's also easier to me than user-defined data type or complex data type. So records to me is much easier. So that is the way I will be referring to these in this discussion. Now most of us, if we're familiar with programming in Basic09, we are familiar with the registers packet. There is a register that is not accounted for in this register packet, and that is the what is it called? Program counter, the PC. But that one is not there for a reason, I'm pretty sure. I've never really understood its use other than the fact that it is used by the operating system and by your programming languages. But apparently it is not necessary in most of your Basic09 procedures, so it's left out, but it would be after you, I believe, unless it's a byte, but I believe program counter is an integer. But anyway, I digress. Anyway, I put this example in here because this is what you would be dealing with if you dealt with it as an array. You would have to remember that 5 and 6 go together, 7 and 8 go together, 9 and 10 go together, and you have to do this little expression to get the correct value. And then if you're doing base 0, these numbers change from, instead of 1 through 10, 0 through 9. And then you have to remember what each one is and what each one does, what it's for. So for the majority of us, this is the easier way to do it. Some people don't use my naming convention. Some people will call this regs and call this registers. Other people have other naming conventions. I prefer reg in capital letters for the type variable, since your atomic variables are all caps, string, integer, byte, real, boolean, they're all cap. I figure a type statement should use all caps so that you recognize that that is a data type. Okay, so I call mine reg, R-E-G, and then the variable I call regs, R-E-G-S, in lowercase. Then the register type is defined as bytes, C, C, A, B, D, P, and integers X, Y, and U. And that means that when you need to refer to them, it's as simple as regs.cc, regs.a.b, .dp, .x, .y, .u. I have never had a reason to use DP. And regs.cc I have not gone out of my way to use, but it was recently made clear to me, and I was able to finally understand that it does serve a real purpose. if for any reason the system call returns an error, CC is going to have a value greater than 0. And if you use the statement error regs.b, it will generate an error message with the value of regs.b. If CC is greater than 0, regs.b holds the error code. So you generate error code regs.b, and it goes to your error trap routine, and your error trap can handle the error. Now, I've always just assumed it was going to work right for the applications I used it for, because mostly I was getting a file size, I was turning echo on and off, I was turning page pause on and off, things like that. So I didn't really experience issues, but I did find that this is definitely useful. So at some point, not right now, but at some point I will be going through my procedures and updating them to all use this after a system call, just in case there is a problem, because otherwise I'm never going to know, and neither are you. So anyway, that is the basic gist of type statements and the way that they are usually used and why you might prefer this. Now, another case is the packets. So let's do this down here. Most of the time you see packet, or we'll just call it packet 32 : byte. And what that does is it defines the packet used to get the terminal settings or current Windows settings, whichever way you want to look at it. But you have to remember what each byte in that packet is, and if any of those bytes are integers, you're back to this again. Well, you could create a packet type, but you're looking at 32 bytes, and if they're all byte values, there's no integer values involved, that's 32 different fields. A 32 field type would look something like this. Let's call it TRM equals, and we're just going to use numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now imagine that each one of these numbers, which would not be valid file names or field names anyway, but imagine each one of these is a descriptive name for what it is. So for example, in base 1, 4 would be echo. And let me see, I need to find out to be certain. Mode 7 is pause. So imagine that you did that with each and every number, using all of these as what it is you're using to define them by. Okay. And then, there's your dim statement. Now, it wouldn't be so hard. It would be turn packet dot whatever. So turn packet dot echo, turn packet dot pause, which would be much easier to read than packet 4 or packet 7 or packet 32. Okay? And again, if it's base 0, instead of 1 through 32, it's 0 through 31. However, a lot of people would not want to type this type statement. Okay? First, it's the figuring it out. After that, it's making a copy of it and storing it somewhere so you don't have to retype it. Okay? I did that with the colors packet, if you will. Okay? I defined a type statement that defined all 16 colors, or actually it was 16 colors, 8 foreground, 8 background. Okay? And it works well for being able to make the code readable, but not everyone wants to type a complex data type like that, which I believe is the reason that the authors of Basic09 called them complex, because that gets pretty long. But that's not the only reason. There is another reason that they called them complex, and I'm going to get into that now. In my testing, as I developed decode, and then later when I was when I was developing decom back in the 90s, and then when I started working on decode in the 2000s, I wrote this procedure. All it does is get the header. Now the header is a specific number of bytes until you get to here. Okay. Sync bytes, module size, module name, offset address, type language, attributes revision, and header parity. That is your standard module header. Okay. The execution offset, procedure storage address, procedure storage size, execution offset, procedure storage size, VDT or symbol table offset, DSAT or description area offset, first data statement offset, first execution statement offset, are not part of the standard header. Now, procedure status, I don't remember for sure. I think it is part of the standard header, but it may not be. Okay. And then module name, length, and procedure name. I've got them all three together because I do believe procedure status is part of the standard module header. And it's followed by the length of the module name as a byte value, and then the module name itself with the high bit set on the last character. Okay. So that's the reason I do this here, which I found there is a easier, shorter way of doing this, but I did it this way when I wrote it, so I didn't see any reason to change it because it still works. What it does is it isolates the last character of the module name and then lands it by 127 and puts it back at the end of the string, replacing the character with the high bit set, so that when it prints out the module name, it prints out the module name the way it would appear in the procedure statement. Okay. So then I go and I print out all the values and in the procedure. This was never intended to be used this way. It was just for testing. But even though it is very complex, I think you can see that it does make it easier to know what you're looking at. But look how many type statements it took. Now, yeah, I could have done it all in one long type statement. But Basic09 has problems with type statements that are too long, or any statement that is too long. First, it wraps it in the source code, in this unpacked version. It will wrap the source statement at the 68th character, and then wrap it again. I believe it's the next 68th character and so on until it's got all of them on the screen and it covers multiple lines. Well, each place where a wrap takes place is a line feed character. The editor, and this is just, I don't know why they didn't fix this, but the editor has a problem with the line feed character. So it, for example, let's say that this was wrapping right here, okay? If you wanted to change module name length : byte, it couldn't find it. Why? Because what it finds is module name length line feed byte : integer or : byte. Okay? That's what it finds. As far as it's concerned, there's a line feed character there. Okay? So it can't edit that line properly. Okay? And I mean, I don't know about you, but I'm not going to go digging up the line feed character to insert into my search string or my replace string or whatever it is, okay, for it to be able to change it. Okay? That's just, I mean, that's ridiculous. They should have accounted for that in the editor, and they did not. But because of it, Basic09 has difficulties. And if the statement exceeds 255 characters, and this is the strange part, Basic09 will still read the entire statement because it's not looking at the source statement length, it's looking at the I-code statement length. As long as the I-code statement length is less than 255 total bytes, you're not going to have a problem. But if it exceeds 255 total bytes when it's compiled into I-code, then it's going to produce an error. I don't remember what the exact error name is, but basically you can consider it to be a source statement too long. And I don't think there is an error code for that. I think it gives you a different kind of error, just usually a syntax error or something, or possibly no error until you quit the editor, and then it gives you a compiler error. So that is the deal with long statements. So to avoid that problem, I break this down into multiple statements. So you've got, or multiple types. So you've got head part 1, which is sync bytes, module size, and name pointer. Head part 2, and it's actually primary. Primary 1, primary 2. Type language, attributes, revision, and header parity. Those are the primary header components in any OS9 module header. Then we get into the optional header extensions. So I call them secondary. Secondary 1 is execution pointer, process or procedure storage size, VDT pointer, which VDT stands for symbol table, DSAT pointer, which DSAT stands for description area. Then secondary 2 is procedure data size, first data statement pointer, first execution statement pointer. And then the final portion is head MN, which is module name, which is procedure status and module name length and module name. Now, I believe that procedure status is part of the standard module header, so I include it with this particular part and not with the optional header extensions. Then I combine the first two by defining primary 1 and primary 2 as head P1 and head P2, and then putting them both into a type called H primary. Then I define H secondary, and I define secondary 1 and secondary 2, defining them as head S1 and head S2. Then I define primary and secondary as H primary and H secondary, and I put them into H prime sec. And then the final type, module header, is prime sec and proc name. And doing this puts everything all the way down to here, and then puts this after it. Okay? These two in here, actually these three in here, just combine these to make them easier to get to. I could have just done head P1, head P2, S1, S2, and head MN, but that would have made it more difficult to know what you were looking at. So I did it this way. So then you dim mHead, which is module header, to the module header type. And then I define a file path byte, a name character byte, and a clear screen byte, and then a format string. Then I open the path to my test file, which in this case is JD, which I don't remember exactly what that is. I don't remember if I made that procedure or which I think I did. I think it's a Julian date procedure that I wrote, but I have to look for the source code to find it. But anyway, I'm using that as my test bed, my test procedure. I get the header from it, I close the path. Then I isolate the last character of the module name, and then I set the module name to the leftmost portion of the string except that character, and then add the landed version of the character back to the string, so that in this case, instead of J and some high bit set character, it will display JD. And I did find out more recently that there is a easier way to do that, but this was the way I did it, so I saw no reason to change it since it worked. Then I clear the screen, and then I print out all the fields. Okay? For each field I have a format string I use print using, and the format string defines the length of this, and the length of this, and the length of this, and their types. So you notice it's S30 and H4. Okay? So this is all one thing. Okay? And then this one I did I6 because it's an integer value. Okay? And then you can see by following it down, there's places where I did an integer instead of a hexadecimal value. And to prove that it works, we have this. This is the output of the JD file header. And you notice it's all hexadecimal values that are left justified and integer values that are right justified. Okay, well, I recently decided I wanted to see if I could do something similar to what IDIT does on the module size, where it shows you the hexadecimal value and then the decimal value in parentheses. So I created another version . And I was able to accomplish this. So you see, now it's hexadecimal values all the way down. The things that need to be integer values are in parentheses, have the integer value in parentheses. And you notice it does print JD. So that's what I did. And coming back over here, this is the original version. This is the version with the integer values in parentheses. I changed the version number to 0.05 instead of 0.03. This is just a test bed, so I didn't consider it to be that important of a change. But what you notice here is the format string is now different as compared to over here. So let's do this so that they're lined up. So you see, that's the format string, the new version. This is the old version. Okay. But you notice what I had to do to achieve it. I had to redo the format string to adjust for the exact length of the number string, okay, which I had to turn it into a string, then trim string it to get rid of any trailing spaces, and then get the length of that string, and then string that length. Okay? So I did all that, and it worked. And then here, there's module size, which is the S30. Then there is this, the module size, which is the H4. Then there's a parenthesis, and then I had to use trim string on this, and then another parenthesis after it, which is S2. Then this is that string, and then another S1. And the reason for S2 is so that it puts a space between this and this parenthesis. So, and I had to do that on all 4 of them. So, now everything else that's in here does not apply to this version. It only applies to this version. I didn't see the need to go back and do all those other things again. So, just for covering it, this is what decode's screen shows after it's done decoding getHeader, the module. This is what the unpacked procedure looks like in Basic09, what the packed procedure looks like in Basic09, and what the header for the packed module looks like in the commands directory. And then this is a list of files that are in the getHeader directory that shows you their file sizes and their file names. Okay. This is the dump of the file. This is the packed module file. These files here are decode's output files. This is decode's Basic09 source listing, and this is decom's Basic09 source listing. So, and this is the dump of the file, so you can see what it looks like in its dumped form. Then this is the decode source code file, and this is the Basic09 source code file taken straight off the disk. And the reason I did that is because you notice that these strings are wrapped. In Basic09, that is not a carriage return. It is a line feed character, and same with that. And that's part of the reason that you have trouble editing lines greater than 255 characters, or actually greater than 68 characters, because Basic09 wraps on the 68th character. I can show you here. That's 70, oh, it wrapped at 76. Okay. This one wrapped at 90. Okay. And it puts a line feed character there and continues it on the next line. I did not do a pretty print version of this, but if I did, you would see that the indentation, well, here I can show you here. I don't need to do that. You can see it right there. It indents it, and then it wraps again there and indents it there. Okay. Showing that this is all part of this. But each one of these places here is a line feed character, not a carriage return. So if you were to try to edit module name, comma, mhead, it wouldn't find it. It would find module name, comma, line feed character, mhead, and it would report that it can't find what it's looking for. Okay. That's something that I think should have been addressed before they ever released Basic09, But I guess they didn't do enough testing to run into the issue to have to worry about it. But it is something that should be fixed. But anyway, that's the problem with long statements. Oh, and on the 255 character thing, the source statement can be longer than 255 characters. It is the length of the statement after it's been compiled to I-code that matters. If the length of the I-code statement is 256 characters or 256 bytes, Basic09 is going to report a problem. Now, I haven't tested it to know exactly, so I don't know if it's going to report a syntax error or if it's going to report a compiler error when you quit the editor. It may report a syntax error when it loads it because it can't finish putting everything into the 255 character limit, and it's not complete because there's something after it. So that's the assumption I'm making, given that there is a 255 character limit to statement length. So that's what I think anyway. But anyway, that is what happens with long statements. So now to come back over to this, that's the Basic09 output. You know, when I save the file from Basic09. This is the decode output. Okay. And you'll notice the type statements are all correct. The dim statements are all correct. And it's because every field and every type was used. Okay. Given another circumstance where, say, none of these were used, that variable was defined, it was used as the entire type, which would be C020, okay? But none of the fields were ever used, okay? Then it could get confused and think that it's this one. Okay? So there's all kinds of ways that it can go wrong if all of the fields are not used. But in this case, all of the fields are used, so it was able to do it correctly. Okay? This is the decom version. Now, this part right here, I revised to make it correct. So you know what it actually looked like. Initially, this is what it looked like. And you can see there were problems if you compare between the two. Okay. So you'll notice that there are 38 variables defined. You'll notice that it says 29 and it adds 0, it adds 9, and it adds 0. 29 and 9 is 38. Well, there was one mirror variable, or what I call mirrors. Okay? It's actually a duplication of one of these, but it has a different token. Okay? But it is otherwise identical. It is the same variable. Okay? This here, the number of atomic type identifiers, refers to this. The number of variables dimensioned, or not the number of variable types dimensioned that were not part of the type statements. Okay. That's not added because it's not counted. Okay. The 9 is the type statements. Each one of these names, TP1 through TP9, counts as a variable. It is included in the total program variables count. Okay, this plus 0 here, which is the subroutines, this procedure doesn't have any. But if it had any, they would be included in the total program variables. Okay, and this up here, total unidentified variables. If there were variables that you dimensioned but you never used them, they will still be counted in the total program variables. There just won't be any reference to them. Okay. Then this here is how many field variables were defined. Okay. This is how many line number references were found. This program, or this procedure, doesn't use line numbers, so it doesn't have any. And down here you have the type, how many variables it includes, and its size in decimal. So type 1 has 3 fields and it's 6 bytes long. Type 2 has 3 fields and it's 3 bytes long. Type 3 has 4 fields and it's 8 bytes long. Type 4 has 3 fields and it's 6 bytes long. Type 5 has 3 fields and it's 34 bytes long. Type 6 has 2 fields and it's 9 bytes long. Type 7 has 2 fields and it's 14 bytes long. Type 8 has 2 fields and it's 23 bytes long. And type 9 is 2 variables and 97 or 57 bytes long. And you come down to the types themselves, and you see that type 1 has 3 integers, type 2 3 bytes, type 3 3 integers, type 4 integers. I skipped that one up there. Yeah, type 3 is 4 fields and 8 bytes long. Anyway, type 4 is 3 integers, type 5 is 2 bytes and a string, a 32 character string. Type 6 is type 1 and type 2. Type 7 is type 3 and type 4. Type 8 is type 20, or type 6 and type 7. Okay. And then type 9 is type 8 and type 5, which is the entire header put in the correct order. Then the variable T0024, which I named it that because I used to use C, a capital C, but I decided to use T as it refers to type. Type 24 is type 9. Okay. Then dimension 3 byte variables and 1 string variable that's 32 characters long. So otherwise I would have named this with a capital C like I did originally. Oh no, I named it a T there too. Okay. Anyway, so you can see there are some differences. But otherwise, this is, from here on down, is the output of DCOM, and it is correct. Okay. So then this is these following files, the following 3 files are output files generated by Decode. This is the raw output. It shows you what the token is, what it stands for, and it gives you the entire instruction and tells you what its relative offset to the beginning of the I-code area is and what its relative offset is to the beginning of the module. Okay. And that is the entire module. So that's why I call this the raw output. This is the variables file. Now I added this list of variable names so I could show how each one of Decode's variable names aligns with the variable that it was defined for. And then when you get down here, it shows 30, but it's actually 29 because module name is the mirror. The 89 points to the description area or DSAT, and the F6 points to the Oh, okay, well in this case I guess they're both pointing to the VDT first. Usually the 89 one, oh, it's an 89. Oh, okay, the 89 and F6 are both mirrors of the same variable. A module name itself would be a, see, 88, would be an 84. Okay, so because it's 89 and F6, those are both mirror tokens. Okay, but I counted one as an actual variable to get the correct variable count. And I counted the other one as a mirror. Okay, then the rest of them are the type variables, the names of the type statements, which proves that there are 38 because it's 39 minus 1. So that's the output of that. Of course, I added everything from there down. It's only from the top down to here that's actually the output of decode. Then this is what the DSAT looks like, or the description area. Okay. The header, the names of all these, I added myself to align things with what they are. Okay. The reason for the misalignments is because I copied this onto the web page, and with these, the way they are, everything lines up with this. Okay. All of this lines up with this. Okay. But I added all that to identify everything. But you notice there are 6 gaps, okay, that correlate with all the ones that say unidentified. And every one of those is a type statement. The first one is 4 type statements. And I'll get back into the breakdown of that in just a moment. Then we have the variable definition table or symbol table. I added this list of variable names so that you would know how it was ordered. Okay. So there's your module name, and you'll notice that the 89 and the F6 both point to the same place. They both point to 2D in the VDT, which is 440026, which points to relative offset 26 from the beginning of the description area. And it shows that it's it points to this second program variable, the first one being the type statement, or actually yeah, it points to the, unless it starts base 0, 0, 1, 2. That couldn't be right. Oh, that's right. I don't know. Anyway, that I'm thinking that should be 3, and the reason why is because, well, let's get back over to this one. That's your first variable that includes everything above it. Then there's 3 bytes and then the format string. So that should be 1, 2, 3, 4, 5. Okay. Or base 0, 0, 1, 2, 3, 4. But instead, it's showing up as oh, 0052. That's the offset of, no, that's where it is in memory. Yeah, okay, so it's correct. I'm not sure what I was looking at here. Something isn't right there, because that should not be 0002, that should be 52. So apparently I've got an error in my output, because if you look over here, the DSAT, that should be 0052, not 0002. Oh, wait a minute. No, that's not right. Okay. This one is not format string. This one is format string. You notice it points straight to the DSAT. Yeah, this one, there's two pointers, but they're both pointing to the VDT because it's a field module name. This one is the string variable dimensioned that points to I didn't put those numbers in there, but 0052, 0020, 4 bytes in size in the DSAT. And it points to data memory. The type variable, 3 bytes, and a 32 character string. Okay, so I can quit scratching my head on that one now. But anyway, so that's what these files are for and how they pan out. Now I'm going to be going over more on this using the web page I created. So come back over to here. Now switch to Firefox. Okay, come over here. This is what the breakdown of the description area looks like with everything sorted into its constituent components. Now you will notice the first integer is the size of the type. The second integer I call unknown. And the reason I call it unknown is because I don't know if it's an integer value, two separate byte values, or the first one is a byte value and the second one is somehow connected to the first byte representing a field, which is the very next byte right here. The number in parentheses going down indicates whether this is prefaced by 00 or 01. Because you notice down here, up here in this one, 00 F7 to 010E. Okay? Because the first one is 010F. Okay? Which means that these are actually connected. Okay? Somehow, I don't know exactly how, but it goes from there 0022 to 0035, from 0059 to 0071, from 009B to 00AB, and so on and so forth all the way down. Okay? I'm not sure what these values mean in terms of how they represent the variable type. Okay? Because between this one and this one is 12, between this one and this one is 14, between this one and this one is 19, okay? Between this one and this one is 16, between this one and this one is 21. So as you can see, it doesn't readily lend itself to explanation. And that's why I need somebody that can look at Basic 09 and see what it's doing when it's packing these things to tell me what it's doing and what these values represent. Okay? By doing that, I may be better able to have decode figure out the type statements more correctly, because it still has issues because of all this. Okay? But you can see all the way down that it's pretty much the same thing with every type statement. Now there is this, and I noticed this when I was working on getHeader. Head P1 and head P2, head S1, or head P2, head S2, and head MN have the exact same value for that unknown integer. Head S1, on the other hand, has a different value. And the only thing I can figure is because it has 4 fields instead of 3. When the first 2 and the 4th one and the 5th one have 3 each. That's the only correlation I can make. And I don't know how to interpret it. So it's the same down here. Now, one thing you'll notice, if there is a string field or a record field or a array field, the offset address and size, the offset being the offset position within the record, and its size are defined first. Since this is 2 different type statements, primary 1 head P1 and primary 2 head P2, they are defined here first, and then the type statement that includes them is defined here. Okay? I still don't fully understand these, but I do notice that all of the ones that have exactly 2 fields have the same value for the unknown integer. Okay? It makes no sense to me. I have no idea what to do with it or how to correlate it. Okay? But anyway, that's how to break down the module header. Or not the module header, but the description area in the module. So there are questions I have, things I don't understand. Somebody that knows how to look at what Basic 09 is doing and tell me what it's doing and what these values mean would help me understand a lot more and help me be able to make decode work more correctly and more efficiently where it comes to user-defined data types and the data stored in the module. One of the things you will notice that I almost forgot to mention, this one, head P1, all you get is the relative offset to the beginning of the variable, which is primary 1, or H primary, which actually down here, H primary is, it's down here. H primary is the variable primary. So at the beginning of primary is this one, and it's 6 bytes long, okay, which is counting from 0, 0, 1, 2, 3, 4, 5. Then at position number 6, we have 3 bytes. Okay? So if you look at it, P1 is 3 integers, or P2 is 3 bytes. So that's how it's defined that way. If you look down here at H primary, it's 9 bytes in size. Okay. So this makes it very difficult because especially, okay, that's 22. Okay, the variable for MN is down here. The only thing you get to go by to connect the two is the fact that it has a size of 22. Okay? That's all you get. Without some other understanding, I have no way of knowing exactly how to connect the type statement to the variable. The only other thing I have to go by is the VDT, or the symbol table. So now I'm going to go back over there. And we'll come back over here to the symbol table. And what you have is the fields that were used, and then the variables that were dimmed to them, either in the type statements or the variable dimmed to the entire thing. In addition to that, what you have in the raw code, and this is the greatest part, in the raw code you have 850048, 890042, 89003C, 890033, 89000F. Okay? All of this from here to here indicates one field. This is the variable. This is the first subfield, second subfield, third subfield, and the fourth subfield. Okay? When decode is doing this, it is making sure to assign these to each other. So this one gets assigned to this one gets assigned to this one, this one gets assigned to this one, and this one gets assigned to this one. And that's how I know they're connected. But that's the only way I have of telling. And when it comes to fields that were not used, I don't have that information. The one thing I do know about Basic09 when it packs modules is it does not include anything that isn't used. So dimmed variables still count towards the total program variables. They still have memory allocated in the data memory allocation, but there is no reference to them anywhere. So you basically have gaps in your data memory map, which if you come back over to here, okay, this would not validate. Oops. This would not validate if there were unused variables. Because there would be gaps. So that's what's up with that. So anyway, now back to this and the complexity. Okay. This proves that this works, because all of that is one big variable. Okay. Now the problem comes if you have to pass a field value to a called procedure. And let's say, just as an example, your called procedure is receiving that as a variable. So let's say it this way. let's say that you've got a complex type or a user-defined type that includes a path, right? So you have a file path or device path included in that type. If it's more than a certain number of levels deep, it's not going to work. Why? Because it's not going to pass a byte. It's going to pass an integer. And the value received in the procedure that it's called is going to be 0 unless the least significant byte is greater than 0. So in more cases where you would want to pass it, for it to be the correct value, you have to make sure you can pass the field. And the problem is, it's how many levels deep. And I don't remember if it was 4, 5, or 6. But this is 1, 2, 3, right? This is 1, 2, 3, 4, 5. Okay? So let's say that you had a type statement that included a path variable, and the path variable was the 5th level down. Okay? And assuming that that's where the problem is, I haven't done any testing in a while, so I don't remember exactly where the cutoff is. But there is a cutoff where it will not pass that value. And since a path number is a byte, we'll use that as an example. Let's say it is the 4th level where the cutoff is. You know, it'll do the first 4 levels, but it won't do the 5th. And your path variable is a byte, and it's the 5th level. Okay? So using this as the example, there's level 1, level 2, level 3, level 4, level 5. Okay? And you pass as a parameter yeah, this is no, that's an integer. We'll use this one because it's a byte. If you were going to pass this, okay, it's 1, 2, 3, 4, 5. If the problem exists at 4, when it gets here, it's going to stop. And it's going to pass an integer value that is somehow related to this field. And I'm not sure, I didn't investigate it far enough. I just said, okay, it's got a problem there. I got to remember that. I just don't remember which field it has the error on. I have to do some more testing. Now, the thing is, because it would be passing an integer instead of a byte, it would be receiving an integer, and since the integer would begin with either 00 or 01 or something like that, the byte variable that you received it into would either be 0 or 1 or whatever value it was, because the most significant byte isn't being read. Okay? And it's not the right value anyway. So, and this doesn't matter if you're passing it as a byte, you know, or passing it as, you know, this whole thing, and you're receiving the exact same thing. It'll be the same problem because it's not going to pass the right value. Okay? That's something that should have been fixed when they developed Basic09, but apparently they did not have that problem. They didn't do enough testing or something, because they did not correct the problem. And as a result, it's something that needs to be looked at. So, because of that, there is only one workaround to it. You take whatever field it is that you're wanting to pass, you dimension a variable of the same type as the field, and then you assign that variable with the field variable, by using the whole thing, right? Be variable equals all this, and then pass that variable in the run statement. Then it'll get passed correctly. Also, just to touch on passing by value. If you pass a variable and you add to the variable plus 0, okay, it is Basic09 is going to send it by value, and if it's a byte variable, the value received is not going to be correct, because once you add that 0 to it, it creates an integer and it passes the entire integer. So you really cannot pass a byte value by value unless you're receiving it into an integer. So just a quick note on that. But so that's basically the gist of complex type statements. Would people want to create a user-defined type like that? Probably not. Okay? They'd come up with a simpler way to do it, shorter field names, so they could do it all in one type statement if they wanted to do it that way. Yeah. Which I've done. Before I created this, I created one where all of the header fields were in one type statement. It was way too long. So that's why I did it this way. Plus, doing it this way allowed me to use the exact names. So that's basically it. Again, anyone watching this video that knows how to look at Basic09 and see what it's doing, I would sure appreciate it if you're able to look at the part where it packs the code, if you could do the following things. First of all, relating to these user-defined types and the description area, if you can give me a breakdown of what all of this means, okay, how to interpret all of those unknown integers, okay, how to be able to differentiate between two different type statements of exactly the same number of variables and same number size, or in the same size value, okay, where one is used and the other isn't, or both of them don't have all the fields used, and so decode is not able to correctly identify it, and it ends up assigning the wrong type, and the other type remains undefined because it can't find any variable that goes to it. I would sure appreciate it. Sorry about that. Anyway, I would appreciate it if this information could be deduced and provided to me so I know how to interpret it properly. The other thing I would ask is if you're able to do that part of the code and look at how things are being packed. If you could look at the data structures that Basic09 maintains in the unpacked state, the variables list, the line numbers list, and whatever other list there is that includes all the comments, unused line numbers, blank lines, anything like that. I'm assuming it's 3 tables. One that's the variables list that has the variable name, its ICode representation and token, token and offset, okay? And possibly whether it points to data memory or VDT, symbol table, or description area. Okay? The line number references, which is all the line numbers as they were typed, which are actually labels in Basic 09, the only valid labels there are, but the actual line number and its token and offset representation, I'm assuming that's what that is, and then everything else, which is comment lines, blank lines, lines with line number references where the line number was never used. There was no go to or go sub or any other statement that used it. So that line number is now ignored. Okay? But the statement still exists. Okay? In some form, I'm sure. Because when it's not packed and you're listing the procedure, it is able to insert the comments where they go, the blank lines where they go, line numbers that were not used, or not determined. Okay? They're still put at the beginning of the line they occurred on. Okay? I know that the rest of the statement and all the other statements are basically rebuilt. Okay? In Basic 09's workspace, it's iCode, and it refers to those three tables for reconstructing your source code. So if those three tables, or whatever form they are, if you could tell me what their format is, what form they take, and if somebody could see fit to modify Basic 09 so that when you go to pack a procedure, it saves those three files, or however many tables it is, to files. Okay? Saves them out to the files. It could be an option where you do Basic 09 dash something that says save those files. Okay? And when you go to pack it, or it could be in the pack command itself, pack dash something that'll pack the procedure and save those files out. Okay? And then provide me with the format of the files, then and a copy of Basic 09 that does it. Then I can start using that to figure it out myself. In addition to the fact that not only could I reconstitute your source code, I could reconstitute every type statement regardless of how many fields were used or not used. So that would help me a lot. So that's what I'm hoping will happen. I'm not holding my breath, but I am crossing my fingers, if you know what I mean. So thank you for watching. I'm sorry for dozing off there toward the end of the video. It seems like this happens to me and I don't even know where I'm doing it until I snap out of it. Anyway, thank you very much, and I'll see you in the next video.